Swayam Prabha. Digital India. Educated India.
Okay, so let us now discuss about further on this ternary force phase equilibria type 1. Okay, I have already drawn and shown you some of the shapes. Here you see all the shapes together. Okay, what you see here, the shapes of the mixture of the phases like liquid plus alpha. This has a prism like shapes, liquid plus beta. This is the liquidous surface. You can see this is the liquidous surface, and then you have three phase regions like liquid plus alpha plus gamma, liquid plus beta plus gamma, liquid plus alpha plus gamma. They look like a long cylindrical, long actually pyramid. Okay, you can see here this is the base and that is the pyramid. Similarly here also, sometimes it is not, there is no apex at the top, but shapes are like that. Most importantly, the four phase equilibria has shapes like a triangle, is like a tetrahedron, but not a regular tetrahedron. Okay, it's going to be like this. One can draw here. I have already drawn that for you. Okay, so this is corresponding to the eutectic, and this is corresponding to the other three phases or the liquid and alpha, beta, gamma. Correct. So now not only that, one can also look at solid phases. As I have already drawn you for the alpha and beta and gamma also. You see here the solid phase between alpha plus gamma, alpha plus beta. Alpha plus beta is very simple. You can draw yourself. It's like this. It's just like this, and beta plus gamma is almost similar, not much different. You can clearly draw it, is same. Okay, and alpha plus beta is also very easy. So therefore, these two solid phases, two phase solid mixtures are very easy, not difficult. The only problem comes for the three phase regions, which are a little bit complex, but you can practice it and see that. Basically, you can take out these shapes from the 3D space model. Correct. Now I am going to discuss with you I think let me go back. This is better, I believe. I think one can see it. You can see it very clearly. Yeah. So I will just show you how the three phase, how these isonormal sections will looks like. As you know, isonormal section is nothing but a section taken at a fixed temperature. So how do you do? I just take a triangle at fixed temperature and cut this three dimensional space model. Here this is done at temperature is T1. T1 is a little bit lower than the melting temperature of TB, but higher than TB and higher than TC. Correct. What do you do? You cut it. What you see here, you have a beta and beta plus liquid zone. This is liquid L. Correct. And one can draw tie lines between the two phase zone of beta plus liquid. That is straightforward and not difficult to understand. Now what to happen if you take it at a temperature T2, which is little lower than the TA melting temperature, but it is above the eutectic temperature between AB. That is the E1 is the eutectic between BC actually here. So what actually happens is that it cuts even on the gamma end, C end. Okay, I am going to show it for when A will be higher than melting temperature also in the board, but let us try to understand the basic things about it. So you have a gamma and liquid plus gamma on the C end cut. It has not yet reached the eutectic between temperature between B and C, and a liquid. Correct. That is also not very difficult to understand. Now if you go to a temperature little lower than that, but still we have not reached the eutectic temperature between B and C, but temperature is still higher than any of the binary eutectics. What will happen? You have alpha, beta and gamma 3 single phase zones, and then liquid plus beta, liquid plus gamma and liquid plus alpha, and in between you have central level liquid, correct. Now different things will come once you take a section which is little lower than this eutectic between B and C, but higher than the eutectic between A and B and B and C, A and C in this particular case. So, you see here, because you have already gone to temperature lower than the eutectic temperature between B and C, you have a triangular region beta plus gamma plus L. This is a 3 phase equilibrium region, and also you have a region beta plus gamma between gamma and beta. Rest of the things are remaining same, liquid remains the center, correct. So, if I still go down the temperature below the all the binary eutectics, that is easy. So, what will happen? You have a triangle between alpha plus gamma, what is known as liquid alpha plus beta, liquid plus beta plus alpha, then between B and C liquid plus alpha plus gamma, between C and B and C which is liquid plus beta plus gamma, 3 triangles between the 3 phase regions, and 2 phase regions extending from this liquid plus beta, liquid plus gamma, liquid plus alpha. At the center you have a eutectic liquid. Okay. So, that is what is happened. It is just above the ternary eutectic obviously, but temperature is below the binary eutectic temperatures. What will happen if I go down below the ternary eutectic temperature? That is what is shown here. You see you have a beta, gamma and alpha at the corners, and central you have alpha plus beta plus gamma obviously, because this is what is the eutectic as we are going to form, and you have binaries alpha plus beta, beta plus gamma and gamma plus beta alpha eutectics, correct. So, that is how it will occur. Now, I am going to draw it for you for a system which is a little bit different, not that this one, because unless and until I draw you will not be able to make it clear. So, I am going to draw this one for a eutectic for a eutectic in which B has a higher melting temperature than A and then C, okay. So, now I can join these 3 points. This is my ternary eutectic. So, A, B, C, this is the temperature Ta, Tb, Tc, correct, and this is E1, E2, E3. So, let me just draw. I will draw a temperature, suppose T equal to T1, but T1 is greater than Ta, but it is less than Tb, correct. So, what will happen? What you get is this, like this. This is how it will look like, beta, liquid plus beta, liquid, A, B, C. Because B has the highest melting temperature, beta will start forming first, unlike the case I shown you on the slides where A has lower temperature melting temperature than C, but B has the highest melting temperature also, but here C has the lower melting temperature than A. So, now if I go temperature which is T2, but T2 is greater than Te1, Te1 is this melting temperature, what will happen? It will be same, I showed you already. So, you have beta here, alpha here, alpha will be smaller, wrong, and these are the regions of what? Liquid, alpha plus liquid, beta plus liquid. Remember, we have not yet touched the eutectic temperature. What will happen if you touch the eutectic temperature? A little bit below the eutectic temperature. That's let us talk. First eutectic temperature. So, T3 is or rather T1 is greater than T2. So, it will be little bit different, obviously quite different. You have alpha, beta and also little bit of gamma. So, alpha, beta and gamma. Then what you are going to have is a triangle. This triangle which is a feature of three phase equilibria between alpha, beta and liquid, and obviously you will have other things like this one and this one, which is as usual. So, you will have alpha plus beta plus liquid, alpha plus liquid, this is liquid, beta plus liquid, gamma plus liquid. This is distinct. Here it is that because the temperature is lower than the first eutectic temperature. So, first eutectic reaction has happened, that is why you have a equilibrium between alpha plus beta. So, now I go to temperatures which is in between which is below even below the eutectic temperature of B and C, correct, or rather sorry A and C. So, A, B, C here. Now, you have alpha, beta, gamma. Okay. So, you draw this triangle, there will be two different types of triangle. One is this, and then you have a triangle here. Correct. This is one triangle. This may not be a triangle. This will be like this. Yes. And then you have this region. This is liquid. This is that. Okay. This will extend. So, what are the regions? This is alpha plus beta plus liquid, alpha plus liquid. This is liquid. Liquid plus beta, liquid plus beta plus gamma, because the third eutectic here E3 it is the temperature is lower than that. So, what is the temperature? Correct. The temperature is lower than T2, but higher than T3. T3, yeah. No. Okay. Higher than T2, but lower than T3. So, and this is liquid plus gamma, that is the one. Now, if you are below this T3, T2, so suppose T5 is less than T3, what will happen? You will have both all the three triangles present, alpha, beta, gamma, sorry, this is the first triangle, ternary equilibria between alpha liquid plus alpha plus beta, and this is the second triangle. Second triangle will be and the third triangle will be here. Okay. This is the most complex one, alpha plus beta plus liquid, this is alpha plus gamma, this is liquid plus alpha, liquid plus beta plus gamma, this is liquid plus alpha plus gamma, this is liquid plus gamma, beta plus gamma. That is how the phase regions, because you have all the three, this is the temperature is lower than all the three you take binary temperature, that is why three triangles will exist, this. And obviously, when you have a three phase zone, in between there will be two phase zone. Here there is a two phase, here there is a two phase, here there is a two phase zones existing. And between these two single phase, there will be two phase between these two also. So now I am going to draw the last one, which is if the temperature is lower than the ternary you take temperature. So T is lower than TE. That is very easy. This is one of the easiest one. Alpha, beta, gamma. That is all. So this is alpha plus beta plus gamma. This is alpha plus beta, alpha plus gamma, beta plus gamma. So you can clearly see how this, how these isotomal sections are getting evolved. From here, very high temperature to two, where temperature is little bit above the first UT temperature, both the two phase regions, liquid solid regions exist. Then it is between first eutectic but higher than second eutectic, the first triangle develops. Then it is between the two, lower than both the two eutectics but higher than the third eutectic. So two triangles develop. So if it is lower than the three, all the three binary eutectic, three triangles develop. And when it is lower than the ternary eutectic, you have all the solid phases present with alpha plus beta plus gamma at the center of these things. That is what. So whatever I have shown in the slides is exactly similar, but only thing is that the temperatures of the regions are rotated as compared to the earlier cases. So that is about the isotomal section. These will come back when you discuss about the solidification of the alloys, correct. So now let us see vertical sections. Okay. So vertical sections are also very important. As you know, vertical sections are taken normally like what? There are two ways we can take. I told you earlier, I am telling you again and again so that you do not forget. So this is B, this is A, this is C. One is taken like this, okay, this is X. Other one you can take is parallel to one of the sides like this. So here we have taken the vertical section by XB or BX. So if I take a plane cut across this will look like this. This is the alpha plus gamma region is existing. This is the alpha plus gamma. Then we have above we have liquid plus alpha plus gamma, and above that you will have liquid plus alpha. Similarly, on the right side you have a beta plus gamma and liquid plus beta plus gamma. In addition to that, because we have taken a vertical section from the one of the ends of the triangle like B. So because that there is a single phase zone B, correct, and you have that. Remember, on the vertical section I cannot draw tie lines like this. This is wrong, not allowed. This is one such way. Okay, there is other way of taking it. This is what is shown here. WS here is parallel to, there are two shown. WS here is parallel to one of the sides of the Gibbs triangle AB, and if you take it, it is exactly similar, except that because you have taken along the side, not along the from the corner on the corners of the triangle. So you have beta plus gamma, alpha plus gamma on the both sides. Then liquid plus alpha plus gamma, liquid plus beta plus gamma above that. Then above that you have liquid plus alpha and liquid plus beta. It is similar to the one, this region, this side is getting repeated on the right side. Similarly, if I take along UV is little bit longer, this is closer to AB than WS. So you have all the regions remaining same. Vertical sections are basically important to know how this phase field appear as a function of temperature. As the temperature is getting down, how the phase field appears. So liquid to alpha, alpha to liquid plus alpha plus gamma, and alpha plus gamma. That is how things happen. So when you discuss solidification, this is how it will happen: liquid plus alpha plus gamma, alpha plus gamma. What does it mean? From the liquid first alpha will precipitate, then the binary Utecht reaction happen, alpha plus gamma will form, finally you will have alpha plus gamma mixture. Same thing on the right side also. That is what it tells, it does not tell anything else. So, on the in comparison to vertical section, the horizontal sections or the astomal sections are more important, they tells you much better story. Okay. So, in the next class I am going to take up, so I have given you some basic idea in these 2 lectures about these 4 phase equilibria. I am going to take up certification of different alloys. Okay. So, we will take up certification of the alloy X, certification of alloy Z and certification of alloy Y. See, this is Y, this is Z, this is X, and we are going to discuss what will happen, and then we will tell you how things, this is not important, how certification will follow. Obviously, we have to discuss this thing using both the space model as well as also using the astomal sections, correct. Let us finish the lecture today, and then in the next week next time we will discuss the lecture on the certification.